In this video, we're going to talk about using trigonometry and bearings. In surveying and navigation, directions can be given in terms of bearings. A bearing measures the acute angle that a path or line of sight makes with a fixed north-south line, as shown in the figure. Here we have our angle, and we're down here below the east-west line, so we're going to say we're on the south line first. And then how far off that south line are we? Well, we're in an easterly direction by 35 degrees. So south is our first, and then we have our 35 degrees off that to an easterly direction. Here we are 80 degrees off north, so we use north first, 80 degrees in a westerly direction. So off this north-south line, we had 80 degrees toward the west. Here in the last one, again, we're up in the upper two quadrants, so we're closer to north. We're going to do north. And then how far off north are we? Well, 45 degrees here. And we didn't go to the west, we went to the east. So north, 45, east. In air navigation, it's slightly different. In air navigation, bearings are measured in degrees clockwise from north. So here's our north line of sight, and we just read 60 degrees off of that. If we're all the way around into quadrants 2 or 3, we'd still go all the way around. From that north-south line, we're measuring 225 degrees. So example 5 here, it says a ship leaves port at noon and heads due west at 20 knots. So we're starting here. A is our port. We head due west for 20 knots, or 20 nautical miles per hour, at 2 p.m. So we've traveled for 2 hours at 20 knots. So we left port here at A, and we traveled for 2 hours at 20 knots, or 40 nautical miles, and we get to point B. At this point, the ship changes course to north 54 west. So here is our north-south line. We've changed to north, and then 54 degrees off of that northern bearing to 54 degrees west. So we changed our direction. Find the ship's distance and bearing from the port of departure at 3 p.m. So we changed bearings at 2. We traveled for another hour going 20 nautical miles. So right here we have another 20 nautical miles. And what we are asked to find is the distance from port and the ship's bearing from its point of departure. So if the boat is up here now at point D, the distance from the harbor is going to be this distance C. And if we step back and look, that is the hypotenuse of this big right triangle. So we want to find that hypotenuse. We also want the ship's bearing from the point of departure. So they're asking us to find this angle. We started out heading due west, and then we turned a little bit to the north. So we have an angle here. We want to know that bearing from the port of departure. So this angle theta we want, and we also want the length of side C. So again, if we step back and look at the big triangle, we need some sides and or an angle to figure out the length of that hypotenuse C. And it's going to take a couple steps to get there. One thing we are going to need is this entire side. We know this chunk of it is 40. So we need to find this side D to finish it off and find out how long it is from A to C. And let's go to the one angle that we do know besides the right angle. This 54 degrees, we can use that to find this angle. Well, together they form a right angle. So 90 minus 54 would be 36. So this is a 36 degree angle here at B, and we know this side is 20 nautical miles. So we have the hypotenuse of this right triangle, and we also have an angle. So we can set up a couple trig functions to find B and D. So let's see here. If we're at the 36 degree angle, we want the opposite side B, and we have the hypotenuse 20. Opposite and hypotenuse is the sine function. The sine of 36 is equal to the opposite side B over 20. And we could also set up a trig function to find the adjacent side D. We want adjacent, we have the hypotenuse, that is cosine. So the cosine of 36 is equal to d over 20. And to solve either of these equations, we're going to multiply the first one. We'll multiply both sides by 20. Sine of 36 times 20 will give us b. And for side D, we're going to multiply both sides by 20, and that's going to be the cos of 36 times 20. So bring up the calculator here. Let's see, the first one we're going to do sine of 36, multiply that by 20. The calculator mode here is in degrees, so we want to do 36 sine, and then multiply that by 20. And we get 11.76. So B is 11.76. And now let's find D, the cos of 36 times 20. So let's clear that. The cos of 36 times 20. And that side is 16.2. Let's round it off. Or let's go 2 decimals, 16.18. So that's approximately 16.18. And that is D, 16.18. So, the entire length of this side, we had the 40 nautical miles from the setup of the problem, and now we have our 16.18, so this total side is 56.18. And we have this side, 11.76 for B. So now we have the two sides, the two legs of the big right triangle. We can use Pythagoras to solve for C. So this would be our first leg squared plus our second leg squared is equal to C squared. So I'm going to square those and sum them up and then take the square root to find C. So clear the calculator, 11.76 squared, 11.76 squared, plus 56.18 squared, and we add those up and get 3,294.49 and take the square root of that. 57.4. Let's round off to a single decimal place there. So we found the hypotenuse, 57.4 nautical miles. So that's how far our ship currently is from port. The other thing they asked us to find was this angle, which is going to help us find the bearing from the point of departure. So let's see, we're going to need to set up an inverse trig function here. And we have opposite, adjacent, we have hypotenuse. We can pick any trig function we want. Let's do tangent. The tangent of angle theta is opposite over adjacent. Our opposite side is 11.76. Our adjacent side is 56.18. And we are solving this for theta. So I'm going to tan inverse this side to get those to cancel. So we're going to have theta equals the tan inverse of our fraction, 11.76 over 56.18. Back to the calculator. So we are going to do the inverse trig function here. So I'm going to hit the inverse key, and all my sines, cosines, and tangents changed to their inverse functions. So I'm going to divide the fraction first, 11.76 divided by 56.18, and I'm going to get that value, that decimal, and then I'm going to tan inverse it. And I got 11.8 degrees. So theta is approximately 11.8 degrees. And again, that's going to help us find our bearing from the point, or the port of departure. So if I set up like a little XY axis here, we know we went off of our east-west line by 11.18 degrees, 11.8. Remember, these nautical bearings, we first look to the north-south line. We're closer to the north. We're in the first two quadrants, so our bearing is going to start with a north, and then how far off north did we deviate? Well, this far. So we need to find this angle, and we know, of course, we have a right angle here. So 90 minus 11.8. 78.2. So that is a 78.2 degree deviation from the north-south line. So we have north, 78.2, and the direction we changed to was a westerly direction. And here's a little simpler navigation problem. This will be similar to a couple assigned in the homework. A ship leaves port at noon and has a bearing of north 45 degrees east. The ship sails 15 knots. At 15 knots, how many nautical miles north and how many nautical miles east will the ship have traveled by 4 p.m.? So we're traveling north to east. Set up an axis here. We'll make the origin our point of departure. So here is our port, and this was at noon. And it left port at a bearing of north 54 east. So we're headed north, or 45 east, and we deviated from there by 45 degrees. So this is a 45-degree angle. And we were traveling at 15 knots, and we went from noon to 4 o'clock. So somewhere out here. This is a 4-hour trip. 4 times 15 is 60. And we want to know how many miles north and how many miles east did we travel. So, we went up this far, and then we went over. So this will be how much distance we have traveled north. Let's just call this side X. And then how far did we travel east? We'll call that Y, just to assign some variables to those ideas. So let's see here. We have a 45-degree angle here. We also have another 45-degree angle here, and this is our right angle. So we can set up some trig functions. Let's see. If we look at our original 45-degree angle, we want the opposite side, and we have the hypotenuse. Opposite and hypotenuse is sine. So the sine of 45 degrees will equal the opposite side y over the hypotenuse 60. And from the same 45-degree angle, our adjacent side is x, and our hypotenuse is still 60. So we could set up cosine of the same 45-degree angle is equal to x over 60. So for our first one, we're going to do 45 sine and then multiply by 60. 45 sine times 60. And we get approximately 42.42 nautical miles. And that was our y variable, so that's how far we've actually traveled east. We went for 42.42 miles. Now let's see what cosine gives us. Cosine of the same 45-degree angle, 45 cos, and then multiply that by 60. And look at that, exactly the same value. 42.42, 42 nautical miles. So we went also north from our port, 42.42. Remember, sine and cosine at 45 degrees on the unit circle. This has a value of square root of 2 over 2. Cosine also has a value of square root of 2 over 2. That's why those values came out to be exactly the same. Okay, a couple practice problems. First one here, team huddle. Plane is 90 miles south, 110 miles east of London Heathrow Airport. What bearing should it take to fly directly to the airport? Remember, air bearings in air navigation are different. You go from your north-south line clockwise. You can go all the way around. We could have a bearing of 359 degrees. That'd be like 1 degree to the left. So use air measure on that. And then there's another one with another airplane one, similar to the one we just did. So pause the video, try those problems, come back, see if you got the right answers. Okay, let's see here. We got a plane is 90 miles south and 110 miles east of London Heathrow Airport. What bearing should it take to fly directly to the airport? So we're 90 miles south. If this is our airport, London Heathrow Airport, we are 90 miles south, 110 miles east. So I should have put this over here. So 90 miles south, we go down to 90, east 110. So we went to the east 110, and we went 90 miles to the south. And let's see, here is our airplane. We're flying in this direction. There's the wings. And it says what bearing should be taken to fly directly to the airport. So remember, these air bearings, here is our north-south line. We want to find this angle. So that would turn us and take us directly toward the airport. So to find this angle, of course, we're just going to find this little one right here. That's the angle we want. Because we know this is 90 degrees, 180, 270. We're going to find this small angle here and add it to 270. That'll be our bearing from the north line. So let's look at that triangle we're interested in. Here's our theta. Well, we have the opposite side and we have the adjacent side. Opposite and adjacent is tangent. So we know the tangent of that angle is equal to the opposite side over the adjacent side, 110. And of course, to solve for an angle, we're going to use tan inverse, so those will cancel. And we'll have theta equals the tan inverse of our fraction, 90 divided by 110. So back to the calculator. Make sure we're in degree mode. We're going to use our inverses this time. So we're going to do 90 over 110 and get that value of that fraction, and then tan inverse. 39.289. Let's see, just round that off to 39.3. Theta is 39.3 degrees. Remember, these air bearings are off our north-south line, so we're going to do the 270 plus 39.3 degrees. So the air bearing we should take would be 309.3 degrees. Here we have an airplane is 160 miles north and 85 miles east of an airport. Pilot wants to fly directly to the airport. What bearing should be taken? So now our plane is north and east of an airport. So let's say our plane is right here, or let's see, 160 miles north and 85 miles east. So our plane is right about here. It has its own north-south bearings. We want to get back to the airport. So we want this to be our flight path. Of course, here's our north-south line. We want to find this angle. And of course, to find that, just like the last problem, we want to find this smaller angle in here, theta. Well, let's see what we know about this triangle. We know this side is 85, and the height here, just like on this side, is 160. So we want to find this angle. Just like the last problem, we have the opposite side from our angle. We have the adjacent side. So again, we're going to use tangent. The tangent of angle theta is equal to the opposite side over the adjacent. So we're going to tan inverse. And our angle theta will be the tan inverse of our fraction, 85 over 160. So inverse is again 85 over 160. And then we tan inverse that value. 27.979. Let's just make that 28. 28 degrees. Tangent's approximately 28 degrees. So this angle here is 28. And again, we have a 90-degree angle, and then 180. 180 plus 28 will give us our bearing. So a 208-degree bearing. Not much homework for this section, just a couple problems. Number 29, number 32.